Let's take a look at the ionic bond first. So during an ionic bond, ions will form, and that's where the name ionic comes from. So charged atoms are formed in this process. So an ionic bond is a way for an atom to fulfill octet by the complete transfer of 1 or 2 electrons from one atom to another. Typically, we don't transfer 3 or more electrons. It's just too difficult. So let's take a look at the example we have here on the screen. At the top, we see an atom of fluorine, and it has 7 electrons in its valence shell. At the bottom, we see an atom of lithium with 1 electron in its valence shell. Neither of these atoms have a full valence shell, so they are both unstable. However, we can very easily make them both stable by transferring lithium's valence electron to fluorine. When we do that, now fluorine has 8 electrons in its valence shell, and lithium has 2 electrons in its valence shell. And they both now have full valence shells. Don't forget that the first shell that we see here on lithium is full at 2. That second shell that third electron was in, it disappears when the electron disappears. So both of these atoms have fulfilled octet, okay? But at the beginning of the situation, they were both neutral. Now that they have transferred an electron from one to the other, charges develop. Lithium becomes positively charged because it has more protons than electrons, and fluorine becomes negatively charged because it gained that negative electron, and now it has more electrons than protons. If you'd like more information, more details on ionic bonding, you can watch the next part of the video, or you can fast forward if you feel like that's enough information for you. So on the left-hand side of your screen, you see what the fluorine and the lithium look like before the electron transfer occurs. They're both neutral, and we can tell because they have equal numbers of protons and electrons. Right? Up here in fluorine, we have 9 protons and 9 electrons. Down here in lithium, we have 3 protons and 3 electrons. Neutral atoms. But neither of them are happy. Neither of them have a full valence shell. Right? But we can very easily fill their valence shells by donating this electron from lithium to fluorine. Right? Once that happens, lithium now has 2 electrons in its valence shell. Don't forget the first shell is full with 2 electrons. So now lithium has a full valence shell with 2 electrons. This electron from lithium was donated to fluorine, and now fluorine has 8 electrons in its valence shell, making it also stable. It has achieved octet. So both the atoms here have achieved stability and achieved octet, right? But in the process, they've also become charged because don't forget, the fluorine gained this electron, so now it has 1 more negative charge than positive charges. It has 1 more electron than protons. So it still has 9 protons. The number of protons here did not change, but the number of electrons did. So now fluorine has a negative charge. It's an anion. Lithium still has 3 protons. The number of protons didn't change, but it did lose an electron, right? So now it has more protons than electrons, so lithium has a positive charge. Okay? So that's what makes the ions develop when we transfer the electrons. And then the ionic bond is just the positive ion wanting to hang out by the negative ion. They just become associated with each other because of that electrostatic interaction, the interaction of the positive with the negative. So in summary, in an ionic bond, if a neutral atom gives away or gains electrons, then it will become an ion. Then the opposite charges just attract to one another and they hang out by each other, forming the ionic bond. So in the picture here, we can see at the top a sodium and a chlorine atom. The sodium has 1 electron in its valence shell, and chlorine has 7 electrons in its valence shell. So the sodium just simply transfers that red electron over to chlorine, and now both of the atoms have a full valence shell. With sodium, the second valence is now the second shell is now its valence shell, and it's full. And chlorine still has that third valence shell, and it's full with 8. So they both fulfilled octet. They're both stable now, but don't forget they become charged. Notice there's a plus sign in the nucleus of the sodium and a negative sign in the nucleus of the chlorine. So this positive and negative hang out by each other. Notice that in A, the sodium and chlorine are kind of far apart, but in B, the sodium and the chlorine have kind of moved closer together. Right? And this ionic bond between sodium and chloride is what we see in table salt, and this is what holds table salt crystals together. So NaCl is the molecular formula for table salt. So in review, ionic bonds form when atoms transfer electrons to achieve octet. The electron transfer creates oppositely charged ions, and then the oppositely charged ions just simply hang out by each other, forming an ionic bond.